Our current question is, how do you guarantee the left-hand side of our quadratic equation will in fact be a perfect square? If the equation is a perfect square, if it has the form x plus n squared, by algebra we know that's equal to x squared plus 2n times x plus n squared. Generally, quadratic equations will be given in the form x squared plus bx plus c. In order for our equation to be a perfect square, it must be the case that b is equal to 2n for some number n, and that number n, when squared, gives us c. Sometimes this happens, but usually it doesn't. In our previous example, we were pretty lucky. We had the equation x squared plus 6x plus 9. So our b was equal to 6. This makes n equal to 3, because n would be 1/2 of b. And n squared was in fact equal to c. N squared equals 9 equals c. And so this does work out to be a perfect square. We had x plus 3 squared, x plus n squared. Now if we don't have that equation, well, we can add something to both sides in order to make the left-hand side a perfect square. And here's how it goes. Let's say you have the equation x squared plus bx plus c. So we're doing the general case. This is equal to 0. Odds are c is not going to be n squared. What we'll do is we'll subtract c from both sides of the equation. This leaves us with x squared plus bx equals negative c. Now I want to add something in this remaining spot. I'll have to add it to both sides to make the left-hand side a perfect square. What is it that I'm going to add to both sides? Well, we saw from before that if b is equal to 2n, our hope is that n squared will be equal to c. If b is equal to 2n, then n is equal to b over 2. And in this c position, we want n squared. So we want c is equal to n squared, which is equal to b over 2 squared. So what we need to add to both sides of the equation is b over 2 squared. So if we do this, then we'll have a perfect square on the left-hand side. And before I work through an example, I'm going to simplify this a little bit, and you'll see something very familiar come out. So let's say x squared plus bx plus, we've decided to add b over 2, quantity squared. Let's simplify this right-hand side a little bit. We have b squared over 4. I'm going to want a common denominator, so I'll make this into 4c over 4. Now keep that in mind. We'll go to the next page. On the left-hand side, we had x, and remember, x plus n quantity squared, n is b over 2, equals, let's go back for a second, b squared over 4 minus 4c over 4, b squared minus 4c all over 4. Now if we take the square root of both sides, x plus b over 2 is equal to the square root of b squared minus 4c over 4. Don't forget your plus or minus. Now if you have the square root of a fraction, you can do the square root of the top and the square root of the bottom. This will give you the square root of b squared minus 4c over 2. And we really want to solve for x, so let's isolate that. Subtract b over 2 from both sides of this equation. Subtract b over 2, subtract b over 2. We're left with, let's put everything over 2, minus b from here, plus or minus the square root of b squared minus 4c. And you might notice that this looks a lot like the quadratic equation. It's just missing the a parts. Well, we'll figure out how to introduce the a parts and get the quadratic equation But let's work through an example before we continue. Let's say someone walks up and hands you the following quadratic equation. X squared plus maybe 10x plus 3 equals 1. Well, we'd like to make the left-hand side into a perfect square. Let's take that 3 and move it over. What we're going to be left with is x squared plus 10x plus something to make it a perfect square equals negative 2. Now what does that something have to be? Well, just a little bit of side work over here. 10 over 2 is 5. We square that, it's 25. This is going to be what we add to this equation to make the left-hand side a perfect square. So, going back to this equation, we'll have x squared plus 10x plus 25. Now if you add 25 to the left, you have to add it to the right. That equals 23. We can simplify this. Quantity x plus 5 squared equals 23. Square roots of both sides. X plus 5 is equal to plus or minus radical 23. So x equals negative 5 plus or minus radical 23. So there's an example of completing the square. Now let's show you where the quadratic formula comes from. Notice we have something very close to it already. We just have to complete the square in the general case. We'll start out with ax squared plus bx plus c equals 0. Now, before we move the c over, let's get rid of the coefficient of x squared. By get rid of, I mean let's turn it into the number 1 by dividing everything by a. Divide by a, divide by a, divide by a, divide by a. What we're left with is x squared plus b over a, x, plus c over a equals 0.
Now what we need to do is move the c over a term to the right-hand side. And eventually we'll add something to the left-hand side to make that into a perfect square. Now what will that something be? It has to be half of the coefficient of x. In other words, half of b over a. So what we're going to add is b over 2a squared. We'll add that to both sides, and that will make the left-hand side a perfect square. Add it to the left, we must also add it to the right. So now, what we'll have on the left-hand side is a perfect square. We have the quantity x plus b over 2a squared is equal to, I'm going to simplify the right-hand side a little bit, b squared over 4a squared. I'm moving that term to the left and the c over a to the right. Now I'd really like everything over a common denominator, so I'll take this fraction and multiply by 4a over 4a. On the right, that gives me b squared minus 4ac all over 4a squared. That's equal to what we had on the left. Some ditto marks there. Now I'm going to take the square root of both sides. That leaves me with only x plus b over 2a on the left. Then on the right, I'll get plus or minus the square root of b squared minus 4ac all over 4a squared, the square root of that entire fraction. I'll scroll down a little bit. Now I'd like to simplify the right-hand side there. Since I have the square root of a fraction, I can take the square root of the top and the bottom. So I have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac, the numerator, over the square root of 4a squared. Conveniently, that's already a perfect square. That turns into 2a. Lo and behold, we have the common denominators for both of these fractions. I'll move b over 2a to the right. I'm left with x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, which is the quadratic formula.